Let's get started. You should have all received an email from me, right? Yeah, okay. That would have gone out yesterday sometime. So what we're doing in terms of lab is we're going to do two modules, lab modules that are based on a project that's funded by a group of women out of a variety of universities, Colorado Mesa University, University of Oregon, I think, Haley Lanier is, I think, from University of Oregon at Eugene, Liz Flaherty from Purdue, who did her master's thesis here, and then there are a couple of other people. And they have a series of modules, and we're going to do two of those modules. So this is part of an NSF-funded study. So it's a study on teaching, but it's also a study on the process of science and all of that, and it fits in exactly with what we're trying to do in this class. So these are for general ecology, and it's based on mammals. So on the web page, if you'll notice, there are a couple of links. Before you respond to that email, you should probably look at those two video clips. There's, I think I've put up two video clips. Watch those. One is an introduction to this whole project. The other one is on behavioral observation. Now, you've done some behavioral observations already. You've made your ethograms and you've worked through and done your sequence of behaviors, and we're going to work with that this week. Okay, so during our lab this week, we're going to be working with that material. The other thing we're doing this week is you're going to start to develop your hypotheses for the experiment that you're going to do. The first one is on behavior, the first module. So the idea is that animals behave in a way that's optimized. They should behave in a way that maximizes their inclusive fitness. So that's our ultimate expectation. What you're going to do, what we're doing with our behavior stuff that we've already collected our comparison with the prairie dogs and the yellow-bellied marmots, is I'm going to show you a technology for how you can assess and evaluate that behavior. And that's a little bit detailed. We'll do that during the lab period. The other thing that happens in this module is they use a slightly different sort of sampling. We used focal animal sampling, and it was continuous. What happens in their module is they use focal animal sampling, but it's not continuous. So I've forgotten what the time frame is, every 20 seconds or something, they look at the target animal, at the focal animal, and record what the animal is doing. So you're going to fill out a data sheet, and you're recording what the animal is doing. These observations have been made across the country. So it's this large database which will be available to us, which shows the same sort of thing for prairie dogs, and I don't think they're yellow-bellied marmots. I think they might be Alaskan marmots. I've forgotten which group of marmots they have. But at any rate, chipmunks, all sorts of ground squirrels and whatnot. And some of these observations are made out in nature, some in deserts, some in grasslands, some in deciduous forests, some in coniferous forests, and so on. And some on university campuses and against other species like fox squirrels and red squirrels and so on. So what you have is the opportunity to compare your results with squirrels in a different scenario. We can, as a class, set up to do these observations in a variety of different places. You may decide you would like to do your observations in a park or in a forest setting or wherever you'd like to be. Okay, so what's required is just a smartphone so that you can get your latitude and longitude, and on this web page they offer some apps, so tips where to get apps, free apps that allow you to do that. And then you have to, if you have a pair of binoculars, that's great. If you don't, that's fine. It works well if you're working with a different person, with two people doing the same thing, so that one can watch and the other one can record and so on. But what you're going to do this week is set up some kind of hypothesis that you can then evaluate, okay? So this is all about the process of science. Once we've done that, we're going to come back and do the module on optimal foraging. We're not ready to do that yet because we haven't gone through all the models yet. There are a few very simple models, nothing with calculus or anything of that sort, no differential equations here. It's all simply add, subtract, multiply, and divide sort of stuff. So very basic, very easy sorts of models. But we need to go through that, and we need your data, right, on the caloric values of these different food items that we had talked about last time. But everyone is aware of that assignment. That would have been on the video. You need 4, you can, now would be a good time to, not right now, but sometime in the very near future. You need the percent protein, the percent carbohydrates, the percent fat, 4, and total calories per gram for the following food items. You want black oil, sunflower seeds. You want gray, striped sunflower seeds. You want safflower seeds. And then you want cracked corn. We may go with whole kernel corn. That would probably be better. Whole kernel corn. So the same stuff you would use to bake pigs, not soured, just regular whole kernel dried corn. You can, I mean, I will provide that material for you. You don't have to buy it. Where do you find those data? You can find it on the USDA website. Some of that data is going to be available on the USDA website. Some of that data will be available on various agricultural supply websites, equine websites that, you know, for people that raise horses and so on, but those data are out there. I've not found it on any veterinary websites, but I'm sure it's out there somewhere. So those are the data, and that's what your assignment is. You're just going to turn in that table, and you want to indicate where you got it. Did you get the data from USDA? And then give me the link for where you got it, okay? All right.
You want us to email that to you?
No, don't please. My email box, I'm so far behind on emails.
Okay.
Okay, bring it in as a hard copy, okay? Yeah.
We weren't supposed to input our squirrel behavior and put it in Excel and email you, right?
Yes.
I just want to make sure. Not
Yes.
to
No, my email, yeah, no, I need that, but that's pretty easy for me to search for, so.
Okay.
I get so many emails every day, and if I right away know what it's about at that moment, I respond to it. If I don't, it gets buried. Okay, so. All right, questions up to that point? Oh, concerning the exam, you've probably seen your scores upon the exam. I've not put up yet the spreadsheet that shows exactly where you are. Because you've had a number of assignments that you've turned in. Most people did really well on the exam. And just as a reminder, the way the grading curve is established, it's based on the top score in the class. So nobody got 100% on the exam, and what that means is that the top score becomes 100%. So everybody else is scaled on that. That doesn't show up on what you saw, right? It shows what the raw score is. When I put the Excel file up that has all of your grades, it'll have your code number and then all the assignments that you've turned in. If you turned the assignment in, you got the full points. So what you realize right away, every time you turn something in, those are almost like free points. So the only part where you have to worry about, did I not get the full points, is on things like exams or if I give a pop quiz or something like that, okay? But if you do the assignment, you complete the assignment, then you get the full points. All right. There were a couple of people that didn't do well on the exam. That's fine, no worries. Lots of these other assignments. And I trust that now that you understand how it works, that you'll do better on the next one. Did everybody have enough time to complete the exam? I noticed there were a number of people that timed out on it, but it's hard to know whether they really ran out of time or if they just went back over and reviewed it again and again and again and waited until the last moment to submit it. Everyone had enough time? Good. Okay. All right. Let's get started then. What we've been talking about is population growth. That email that you got is completing what's described in that email are additional free points. Okay, so we've been talking about population growth. I don't know if you guys have been paying attention to the COVID-19 data that's coming out of CMO. You guys don't follow that stuff.
I haven't in a while.
Pardon?
I said I haven't looked at it in a while.
Yeah, it's pretty remarkable. Actually, the university is pretty good at presenting it in a way that doesn't look quite that scary. Okay, and that's because they want to keep you reassured. But in fact, if you look at the data, it follows a pattern that does that. Okay, they will release today's data sometime right before noon is what they've been doing it. I think on Friday when they posted the data for Thursday, we were almost at 300 cases. By October 10th, we will be somewhere between 600 and 800 cases.
For the campus alone?
Yes. Okay. So we are in the explosive phase of that. There are some people that don't take that very seriously. For example, in lab on Friday, we were out there watching squirrels, and there was one group of students, and you're supposed to work in pairs, and there were 3 guys. They came late, and they sat right next to each other. They all took their masks off while they were out there, so they were sitting like across the table from you, right? And I'm sitting there thinking, well, this is pretty stupid. But in the defense of those students, right, they see images like Donald Trump at rallies, right, without a mask, no social distancing, nobody's wearing a mask. So the message is not to take this disease very seriously. It is a serious disease. Right now in Cape Girardeau, right, 5% of the population in Cape Girardeau is infected. That means 1 out of every 20 people that you encounter has COVID. Whereas maybe asymptomatic, may not have a fever, but has it and is spreading it. So when you go to the hardware store or you go to the grocery store and that sign says mask required and you walk in, and there'll be somebody in there without a mask, right? So they're not protected, well, you're not protected either. Because if they talk or breathe and that stuff comes at you, this mask is not perfect. It filters out some, but not all. An N95 mask will filter out roughly 95%. Your mask filters out perhaps half. Okay? So your mask is filtering out half, okay? So 2 people come into contact with one another wearing a mask, reduces the likelihood of you getting it from the other person by 75%. Because this filters out half, that other person's mask filters out half, so if they're spreading it, half the virus is withheld. Now you have half the load coming at you, you filter out half of that, so you've reduced your chance by 75%, okay? But that only works if your nose is covered too. A lot of people walk around with the mask either as a chin guard or just covering their mouth because they think the virus just comes out of their mouth and they're breathing softly or something, it comes out of your nose too, okay? At any rate, by October 10th or so, we will have gone, so this time next week, we will have gone to between 600 and 800 cases on campus. So that's a period of exit, unless everybody got super scared by Trump being at Walter Reed Hospital with COVID, right? Now everyone is wearing the mask and so on, but it goes up like that. Now, one of the things that's, you could do this nice little comparison. Compare what happens with the students versus what happens with the employees. The curve for employees is much lower. It goes like that. Well, the difference is that the employees aren't gathering socially. They get off work, they go home, right? Open up a 6-pack of beer and watch football or something, okay? They're not socially active the way you are. I mean, they encounter other people on campus, but not to the extent that you do. You're stuck in these classrooms, you're walking across campus, you're going to your dorm or your apartment or whatever, you're encountering people all over the place. They don't. So you have a greater exposure, and that's why it's growing like that. The point is that COVID is growing, right, following the equation dn dt equals Rn, okay? So that's exponential population growth. And it's going to do that until something happens. Well, the same thing happened with the human population. All right, so the human population from the time of Jesus, how many people were on the planet at the time of Jesus? Counted in the millions, okay? Can't be very precise, right? But it's certainly less than 100 million, probably less than 50 million, probably somewhere in the neighborhood of 5 to 10 million, okay? So that population goes along like that. Here we have the year 2000, here's the year 1000. And at the year 1000, the population has increased a little bit, but not by that much. What was the world like in the year 1000? Well, fundamentally different than it is today. Okay, that's it was in the year 1000 where Constantinople was involved in all of these battles between Eastern cultures and Western cultures. That was the time of the Crusades. It was during the time, all the issues in the Middle East date back to the Crusades. If you think that you're going to make a couple of deals to get the Israelis and the Palestinians and the Saudis all together and happy and smiling and buddy-buddy in one 4-year term, think again. This is a conflict that's been going on for more than 1,000 years. It's pretty baked into the system, okay? It's also where the phrase, in the land of the blind, the one-eyed man is king. That phrase comes from a battle for Constantinople. And the victorious army, the general of this particular army, took all of these other soldiers, and there were about 1,000 of them, and they gouged the eyes out of each soldier, save one. And on one remaining soldier, they gouged out only one eye. So here's this one guy, and he's got one eye, and he's supposed to lead these 900 other men home. Pretty impressive, eh? Oh yeah. Different times, right? We weren't all warm and fuzzy, touchy-feely, happy-go-lucky, peace, love, dove, flowers, incense, beads sorts of people, right? At any rate, the human population does that. So right now, in the US, we have about what is it, 370 million people, 350 million people, something like that. We have 5% of the world's population. And what percent of the world's COVID-19 deaths?
Probably 20.
20%. So it's actually better than we have 5% of the world's population, but we consume 50% of the world's resources. Okay? So there we are. Okay? How long can that go on? That's the question. And the answer is not all that long. If you look at this sort of time scale here, clearly what's happened is when I was born, right, there were, what, 100 and some odd million people living in the U.S. So the human population in the U.S. is almost doubled now for the second time since I've been born. So the doubling time for the U.S. population is now around 40 years, somewhere in that ballpark. Uh-oh. That means by the time you're my age, instead of being 350 million people, there will be 700 million people plus living in the U.S. Legally, illegally, doesn't make any difference. They're here. So what does that mean for your standard of living? What it means is your standard of living is going down. It's going to be worse than mine. You can have all your tablets, you can have all your computers, have all your electronics. Your standard of living will be worse than mine. Okay? I don't have a big house. I have a little house, but I have a lot of land. Okay? It's awesome. I sit out on my patio in the back and I'm watching the deer go by. You know, I've got a family of skunks, which is living over on one corner of my property. I've got dogs. You know, I've got all these bird feeders. I get to watch the birds, the squirrels, all that cool shit. My brother, who lives in Los Angeles, has a house which is smaller than mine, right? It's a $1 million plus house. He pays about $15,000 a year in property taxes. Okay, I pay less than $1,000. Okay, and right, he's got this little. His backyard is as big as this table. He doesn't even have a mower. COVID shutdown, you know, he's locked in this little tiny house. It's perfect, okay? Me, COVID shutdown, I go outside, play with the dogs, watch the deer, watch the birds, play with the squirrels, do all kinds of fucking, go out into my woods, you know, make up some wood. It's awesome. But obviously, if the population doubles again, what's going to happen to your rent? What's going to happen to the cost of your house? What's going to happen to the cost of gasoline? What's going to happen to the cost of your groceries? It's going to go up because the demand for all of that stuff is going to increase. The supply will not increase. How do you know the supply of food is not going to increase? Well, if we're going to grow more food, we have to do one of two things. We either need to plant more acres, or we need to double the productivity. Can we plant more acres of land? Well, part of the problem is, as the cities expand, because the population is growing, the acreage available for agriculture goes down. Some of the best agricultural land in the country is being converted to suburbia. Right? There are field sites that I went to when I was your age in college that are now parking lots for Walmart. You know, I have in my field notes, I go down to this, and you get there and you go, holy, it's not there anymore. It's like a mega mall or something. So that means we have to double the output from the agricultural land that we have. How do you do that? Well, what's the equation for photosynthesis? The equation for photosynthesis is what? H2O plus CO2 with sunlight, okay, gives you C6H12O2 plus oxygen. Okay? That's the equation for photosynthesis. So, where does all the oxygen you breathe come from? It comes from plants. Before plants, there were no animals. Plants came first. Had to come first. There was no oxygen on the planet until plants got here. Okay? Plants produce the oxygen. All the sugars, all the carbohydrates that you get come directly from plants. So now, what can you do here to increase the rate of photosynthesis? You can't increase the amount of sunlight. As you plant your crops closer and closer and closer together, you're actually reducing the amount of sunlight available to each plant because they shade each other. So you're limited there. You can't plant them closer together. Can you increase the amount of water? Well, I suppose here a little bit, right? But we have problems with the soil getting too wet. Out west, you can't increase the amount of water because there's not enough water to go around. Can you increase the amount of CO2? Well, we're working really hard on that, right? We're dumping CO2 into the atmosphere at a phenomenal rate, but it isn't resulting in an increase in photosynthesis simply because they're limited by the available light and by water. So can we double agricultural output? No, we can't. Can we increase it by 50%? No. Maybe with genetic engineering we can increase it by 5%. But we can't double it. In other words, we're in a world of hurt. There's a problem. So the question is, how do we solve the problem? We want to do something which is going to cause this to change. Well, here's what the equation looks like. We have dn dt, so change in population size relative to change in time, is equal to Rn times 1 minus n over k. So there is over here a k. And as the population approaches k, it's going to level off and then asymptote out at k. K is referred to as the carrying capacity. What is the carrying capacity? Can we figure out what the carrying capacity for humans is? Absolutely. It's pretty easy to do. All we have to do is make a graph that looks like this. So here we have population size, and over here we have, let's change this equation just a little bit. R is really equal to the birth rate minus the death rate. So let's make a graph of B and D. So what happens to the birth rate as population size increases? Birth rate increases? So there we are. We have the current population. We're isolated in this room. Okay? So all the reproductive activity that's going to happen happens in this room. Now we double the population. More men and more women. Does the birth rate go up? We double it again. Pretty soon we're standing shoulder to shoulder. How much sex is going to take place if we're that crowded? Not a lot. Okay? It turns out that as the population becomes more and more and more crowded, the birth rate goes down. Part of that is because there's less food available. So you don't have as many calories. You don't have as much nutrition to bring the baby to term. You don't have as many opportunities for courtship and mating and all of that sort of stuff. So the birth rate goes down. What happens to the death rate? What's the death rate like in big cities versus little towns? It's higher. Traffic's worse. More people get killed in car accidents. More people get killed in aggressive encounters, bar fights, gunfights, gang warfare. Okay? So the death rate goes up. When births equals death, when B is equal to D, then R is equal to 0. That's when you're at that asymptote. So there, that's the point. Births equals death. That's the carrying capacity. So we can figure out the carrying capacity. All we have to do is look at the birth rate against population size and the death rate against population size. Draw those two lines. Where they intersect, that's the carrying capacity. Does the carrying capacity change? Oh yeah. Carrying capacity is a function of whatever the limiting resource is. What are the resources that limit us?
Food, water, shelter.
Food. Water. What's another big one?
Shelter.
Yeah, shelter. Just like a cockroach or a rat or a bat, same things. Any other resource that we depend on pretty heavily?
Energy.
Oil. How many of you are wearing strictly cotton or wool? Nobody has any synthetic materials on their body. You all, each and every one of you is wearing synthetic materials. The elastic band in your underwear, right? Your shirt is some sort of polyester blend or something, right? That's all made with oil. Your cell phone, made out of oil. Plastics, made out of oil. The lenses in your glasses, made out of oil. Okay? Your headband, made out of oil. Your belt, probably synthetic, made out of oil. Okay? You need oil. I know, we're going to solar power, it'll be awesome. Okay? The solar panels, made out of oil. The drugs you take, made out, well, not grass, okay? But the medicinal drugs you take, made out of oil. The party drugs you take, made out of oil. So how much oil is there? Well, hell's bells, the US has just gone from being an oil importer to an oil exporter. Right? So we've got nothing but oil. Or, what's the issue? Where do we get our oil?
Fracking.
When I was a kid, I lived in Southern California, and I'd go to the beach, and all along the beach, there were oil pumps. They looked like metal horses. They're just doing one of those, just pumping oil out of. By the time I was in high school, most of them were shut down. By the time I was in grad school, they were all shut down, just standing there rusting away. And the reason is because the oil that was underground was too hard to get. It no longer made economic sense to run that pump to try and get the oil because you spent more energy extracting the oil than you got in return for the oil that you pumped out. So they shut them all down. It's only when the price of oil went sky high that people started to reactivate those things. Back in the days when W was president and oil was selling for $100 a barrel. What does oil sell for? What did oil sell for under Clinton? $17 a barrel. By the time W got in, it was $100 a barrel. What is it now?
They were giving it away.
They couldn't get rid of it. And once the pandemic started, they were giving it away. They were paying people to take this oil. They couldn't get rid of it. That's why the cost of gas dropped down below $2 a gallon. But we're not. We opened up the economy again, and now we're using the oil again. Okay? So now it's about $40, $50 a barrel, somewhere in that ballpark. Part of that supply of oil that we get now is a result of fracking. So what's happened in Oklahoma as a result of fracking? Is Oklahoma in earthquake country? No, it's not. However, in Oklahoma, they're getting something like 2,000 earthquakes a year. And that's a result of shifts in the bedrock and whatnot as a result of fracking. Is there an environmental price to be paid for fracking? Oh, absolutely. Okay? Environmentally, it's dangerous stuff. How long can we continue fracking? There comes a point at which it will no longer make economic sense. Where does oil come from? It's the decaying bodies of plants and dinosaurs from the Cretaceous. So it is a renewable resource. Of course, the problem is that it renews at a rate of about 100 million years. So 100 million years from now, there'll be plenty more. That'll be great. So your distant progeny will at some point have access to oil again. Solar, we'll solve it with solar. Probably not. Not if you live in Alaska. Not if you live in Northern Europe where there's so little sunshine. Okay, if you live in the desert, great. They have these solar arrays out in the desert, which are incredible. The problem is, there's a lot of biological life in a desert, and when you put up the solar array, you've basically wiped it out. So there is an environmental cost to be paid. So how many millions of acres of desert are we willing to sacrifice for your access to free energy or cheap energy? And there simply isn't enough desert land available to give us all the wind turbines. Wind turbines are awesome. Love those things, except for bats and birds, right? You can, as a biology student, make a living working for energy companies doing surveys for dead birds and bats on wind farms. I've had a number of graduate students who started their careers working for consulting companies. All they do is walk around on wind farms, picking up and identifying the dead bats. Okay? I have about 1,000 bats in the freezers upstairs that came off of a wind farm. Okay? The bats are flying along, and they come close to one of those turbines. They can detect the turbine, they know it's there, but the sudden change in pressure gives them a spontaneous pneumothorax. Their lungs collapse, and that's it. They fall to the ground, they're dead. So, okay, who cares about bats? Donald Trump, in Scotland, he has this Turnberry golf course and golf club in Scotland. And the Scots wanted to put up a wind farm offshore. And Donald Trump fought bitterly to prevent that because it would ruin the view from his golf club. Okay? So it's not without controversy. So, where's our energy going to come from? You're going to pay more for it, whatever it is. Electric vehicles, it'll be the solution to all of our problems. Why do electric vehicles solve no problems at all?
The energy it costs to make them.
Well, yeah, I mean, and the lithium batteries and whatnot, lithium is a pretty toxic, nasty stuff. Somehow you have to figure out what to do with all this lithium that we're going to have floating around. So where does the energy for an electric vehicle come from?
Coal power plant.
From a coal-fired power plant. So all you've done is change the place where the energy is being converted. You can either convert it right in your car, or you can convert it at the coal-fired power plant. Same problem. The amount of pollution is just the same. It's just now, instead of it being coming out of your car, it's coming out of the coal-fired power plant. Great. You've not solved any problem at all. But Tesla has convinced us All right. So let's look at this graph one more time and think about the consequences of doing nothing. Here's what happens. Here's our carrying capacity. If our population approaches carrying capacity slowly, everything is neat and groovy. If the population increases a little bit more quickly, it oscillates around the carrying capacity. We had an interesting example of that when Reagan was president. There was a famine in Ethiopia. So in other words, the carrying capacity is not a constant, and the carrying capacity dropped. So the people in Ethiopia were at their carrying capacity, and because of the famine, the availability of resources decreased. The same will happen to us when we run out of resources. Suddenly the carrying capacity is lower. So what happened to them is their population went into one of these declines right there. And we saw these images on TV, on the nightly news, of all these starving kids in Ethiopia, their bellies distended from malnutrition, their eyes bugging out, their arms just skin covering their bones, right? They're so weak and so malnourished they can't even cry. The bugs and flies are just all over them, you know, looking for a free meal. Really pathetic, sad. So as Americans, we responded by sending them care packages, candy bars, right? Stuff like energy bars. So we send all this food, and the kids start to get a little bit healthier, and we say, oh, we solved that problem, and we turn away. And of course, what happens is, because we sent them all that food, everybody feels a little bit better, and they do what humans do. They started reproducing, and the population went back up. And they're still in a famine, they overshoot the carrying capacity, and then they drop again. Suddenly, a year later, it's back on the news. Kids in Ethiopia are starving. We send more candy bars. The population recovers, shoots up, exceeds the carrying capacity, crashes again. This went on for years, until finally it started to rain again. And then everything settled down. The point is that carrying capacity is not a constant. It can change. If the population grows a little bit faster, the oscillations are more severe. If the population grows faster still, the population crashes. So you want to be somewhere between there and, ideally you want to be right there, recognizing that the population, that the carrying capacity is not constant. There is one other scary part of all of this, and that is this. We think that the population is in, we, meaning the layperson, think that the population is in an SAD. What that means is that it is in a stable age distribution. It's not. One of the consequences of that is this. Even if you do everything right, the population can grow and then do behavior which appears to be these random fluctuations. And that's referred to as chaotic population growth. It isn't random, okay? It's chaotic. And the problem with chaotic population growth is that it can very easily go to extinction. The problem is, once we enter into chaotic population growth, we've lost all control. There's almost nothing you can do to salvage the situation. there's almost nothing you can do to any of those parameters in the model that make it better. In other words, because we're uncertain about where the true carrying capacity is, because it's not constant, and because we certainly don't want to overshoot the carrying capacity, because when we do, there's starvation and disease and famine and misery and pain and suffering, and because we certainly want to avoid chaotic population growth, it's clear that we need to do something. So the question becomes, what do we do? So we have a couple of things we can look at. Oh, well, first of all, what happens to population growth if n is equal to k? What is n divided by k if n is equal to k?
1.
1. What's 1 minus 1?
0.
0. 0 times a positive number, 0. So the change in population size is 0. What happens if n is smaller than k? This then is a number less than 1. 1 minus a number that's smaller than itself is a positive number. A positive times a positive is a positive. So if n is less than k, the population increases. What happens if n is larger than k? Then this is a number bigger than 1. 1 minus a number bigger than itself is a negative number. A negative times a positive is negative. So the population increases. In other words, if n is equal to k, you go here and you stay there. If n is smaller than k, you do that. If n is larger than k, you do that. Okay? Good. So now, we know that R is B minus D. So what can we do to reduce the birth rate? We have two options, it seems. One is to decrease the birth rate. The other one is to increase the death rate. Increasing the death rate is more fun. Tell everybody, take your damn mask off. Party. That'll increase the death rate. How many people in America have died as a result of COVID? And, importantly, just as the university infection rate statistics, that only counts students that go to the health center. It doesn't count students that go to the hospital. It doesn't count students that go home. So it's undercounting what the true infection rate is. Okay? But how many people have died in the US and this is an undercount, right? Because there are a lot of people that died that we're not counting.
Over 200,000.
Yeah, it's yesterday it was 209,000 people. How many people died in Vietnam? How many Americans died in Vietnam? 50,000. Holy fucking shit. 50,000 18 to 20-year-olds. Most of them. Some of them are a little bit older. That was a huge, I mean, the social change in this country, and most of them were Hispanics and blacks and poor people. That's why most people didn't give a shit. Okay? There was a lot of social unrest in this country for 50,000. How much social unrest do we have as a result of 208,000 in a very short period of time? Fuck, we don't care. How many people died in 9/11? Hell, we have these annual surveys. Read all the names. How many people died in 9/11? 3,000. We're talking about 210,000 now. We don't give a shit. How much does that 208,000 affect our population growth. Look at that curve. You can't even see it as a blip. The Germans killed 6 million Jews in their concentration camps. You can't even see it as a blip on that curve. In other words, we need to really go out there and start wasting people to make a difference. We got to kill lots of people to make a difference. And we can't mess around with old people. Old people don't matter. I don't matter. Your parents don't effing matter. They are done reproducing. You say, no, man, guys can reproduce until they die. Sure they can, right? Everything might work, but it needs a partner. So how are we going to up that death rate? Execute all the prisoners. Anybody in a maximum security prison, we'll off them. Put them in gas chambers, that would be sort of, hang them, firing squads, whatever. Fry them in the electric chair. That's cool. Behead them. Do what the French did. Do you know why the French invented the guillotine? So this is just for your liberal arts part of your degree. Why do they use the guillotine? Because the traditional way of doing it, I mean, what are the hanging and chopping their head off. Okay? Hanging, the way it's supposed to work, is your body weight drops, your neck is snapped, like that, you're totally paralyzed. You may not be dead right away, but you're totally paralyzed. You're not going to go flopping around. But most hangmen weren't particularly good. So the person would dangle there, sometimes for an hour or so, slowly suffocating, pooping and peeing all over the place, doing one of those things. It was a pretty horrific way to die. That the guy chopping your head off, usually they weren't very good. They'd miss, bury it in the middle of your shoulder, bury the axe in the middle of your butt, bury it in the middle of your butt. Finally, they'd get the target and whack your head. And then you were dead. And it was messy. So what they did instead is they figured out the guillotine. Strap them in like that, nice clean cut, head rolls into the basket, laying upside down, looking up. The brain is still alive, the eyes are open. Who knows, for 2 minutes the person is still looking around going, holy shit. Isn't that awesome? Figuring out ways to kill people, it's great. Sort of fits with our culture of the day, all the, slasher movies and shit you get on TV. It's great. Seems sort of weird though, don't you think? How else could we increase the death rate? Give AIDS to more people.
War.
Yeah, we're good at war, especially against brown people. We love bombing brown people, shocking out, hell yeah. Boom. It was great. You can't even see it on the graph. We got to get a whole heck of a lot better at killing people with war if we're going to expect war to solve the problem. Yeah, so maybe increasing the death rate, and doctors are doing everything they can to keep you alive. You have some weird genetic disease, the doctor is doing everything they can to keep you. You have type 1 diabetes. We have all these strategies to keep you alive so that you can reproduce and pass the diabetes on to your kids. We have all these modern medical miracles designed to keep you alive. I mean, that's what doctors are all about, right? It's not going to work. So maybe we need to reduce the birth rate. How do we reduce the birth rate?
Limits on how many children people can have.
Like the Chinese, the one-child policy. What were the Chinese walked away from that policy? Why?
Because they didn't have enough people to take care of the growing old population because there weren't enough new people to be born.
It's even more basic than that.
It's a bunch of men and no women.
A lot of guys and no girls. Because the Asian culture is patrilineal. Okay? Sons matter, daughters don't. Sorry, ladies, but in Asian culture, you don't matter. Okay? So everything is through the paternal lineage. So here, all these peasant women, they give birth, it's a daughter. They know that they can only have one, so they take the daughter out to the rice paddy, drown her. Bury her, she fertilizes the rice fields. And they try again until they get a son. And that's the one they keep. So now, 20 years later, you've got this huge population of males and almost no daughters. Now imagine you are the father of a daughter. And you've got like 50 guys wanting, they don't even want to date her, they just want to marry her, okay? 50 guys that want your daughter. What would you do? What would you do if you were the daughter? 50 guys, and you get your choice. Which one do you want?
The richest one.
The richest one, the one with the most resources, the one with the most power. Should be okay if he didn't have a real bad case of acne and, you know, was kind of semi-normal or something. That'd be all right. But, yeah. So, because of the social upheaval, the Chinese said, okay, maybe not. So they got rid of the one-child policy. So there was this short, you know, cessation in the growth rate of the population, but it's temporary. So how can we reduce the birth rate?
I guess you can chemically castrate.
Pardon?
I said, I guess you can chemically castrate like a certain percentage of the population.
Which percentage? Poor people. We did that. We did that in New York City, right? Back in the 50s and 60s, women would go into these clinics, right, in these free healthcare clinics, either for an abortion or for some sort of an exam, and the physicians would sterilize them. Without the consent of the woman. We did that in Pakistan. When Nixon was president, they went to India and Pakistan, and they wanted to control population growth in India and Pakistan. So they set up all these clinics. And guys would like, because they knew that if they went into this tent, they would come out a little bit later and they would get a free transistor radio. Back in the day, you could have these little transistor radios about the size of your phone, little 9-volt battery in there, and you could pick up AM and FM stations on your little transistor radio. Back before, you know, MP3 players, back before, you know, Walkmans and all that, it was the little, of course there were no FM and AM stations, but it was a cool looking little thing. All these guys go into these places to get these things, and all they had to do was sit down here, you know, spread your legs, we're just going to go up right in here next to your nuts, just tie these two little tubes here. In other words, they tied their tubes. They gave them vasectomies. The guys didn't know it. Of course, when people figured out what was going on, there was holy shit to pay. So we've tried that before. And it didn't. Supposedly, they tell me we're a Christian nation. Okay. So what else can we do?
Educate people.
Yeah, so educate people, yeah, like in a sex education class or something in high school, right? So what did you learn in your sex education class in high school?
If you have sex with more than one person, you're getting all that other person.
You're going to die from all these diseases. So sex education in your school system was designed to scare you. Because they don't want you having sex until you get married. They want you to save yourself for Jesus.
Our pastor teaches that.
Yeah. So, what was the standard operating procedure for sex and whatnot at the time of Jesus? Was it one man, one woman? Read the Old Testament, where it explains how many wives you can have, who you can buy as a wife, what animals you can sleep with. I mean, all that stuff is there. The Old Testament is fundamentally different from the New Testament. Okay? A lot of contradictions. Why? Because times change. All right. What do we do? I mean, sex education simply doesn't work. And the reason it doesn't work is because we're trying to satisfy all these different constituencies. And if you're in a conservative place like Cape Girardeau, Missouri, and you're in the school system, and you start talking about birth control, holy shit. Can you imagine the fights at the school board meetings? It will be ugly. So they know they have to provide some sort of sex education, so they fall back on the Nancy Reagan model. Just say no. Now, how many of you, there you are, your hormones are raging through your body, and you're going, nah, no. Didn't work when I was a kid. It's unlikely that it works today. So we don't do a very good job of sex education. We don't teach kids what they need to know. We separate the boys from the girls. What the hell's that all about? All right. So how else can we bring the birth rate down? Let's think about the birth rate in a slightly different way, shall we? Let's only pay attention to women. Forget the males. In models of demography, they never talk about the males. Why? Because males don't matter. What is a male? A male is a female's way of getting sperm from one generation to the next, and that's it. There's an infinite supply of sperm out there, whatever. Males don't matter. The part of the population that matters when it comes to population growth is the female part of the population. It's the female part of the population that controls reproduction. We need to think about the females. So let's do that. Let's make a graph, and on this axis is going to be age. So we're starting off at the age of 0. There's a newborn baby. And here's the age of 100. There's 50. There's 25. There's 75. Let's see, there's about 37. There, like that. Okay? So on this axis, let's put something called reproductive value. Or let's just write down fecundity. We'll talk about reproductive value in a bit. So what is the fecundity of a newborn baby girl? 0. At what age does a girl become capable of reproduction?
After puberty.
Yeah, when does puberty start? What is the youngest female that you know of to have given birth? 5. There's a 5-year-old girl in Tijuana that gave birth. How about in the U.S.? An 8-year-old girl in Chicago. Where in Chicago? On the south side of Chicago. Why is that important? What is the south side of Chicago like? poor, okay? What happens in a poor place? What's it like? Is it grins and giggles, fun? Let's go out and party, man, have a good time. What's it like? It's rough, it's hard, it's stressful. What's it like in Tijuana? It's stressful. The thing that unites these two together is the stress. Now, the 8-year-old girl in Chicago was raped by her uncle. Okay? So she didn't initiate anything. So in stressful circumstances, what happens to development? We talked about that a little bit in before the last exam. How does stress, when the environment is unpredictable, okay, what should you do in terms of your reproductive strategy?
Accelerate.
Depends. If the unpredictability influences offspring survival, you should reduce expenditure of energy on the offspring. If reproductive survival influences the adult, you should maximize reproductive effort. So what happens in stress is people tend to become more reproductive. They accelerate it, okay? So they accelerate it. Development moves forward. So this young girl goes into puberty very early in this stressful situation. She is maximizing her opportunities for reproduction. Not willingly, but that's what her body is doing. Okay? So, on average though, when does it happen? Under more normal circumstances, when does reproduction begin? When did, I'm not going to ask any person, and we don't care about males, we care about females. When do most females go into puberty? Think about your school. When you were in school, did girls start developing breasts?
Middle school.
Middle school, right? So at roughly the age of 12, okay, 11, 12, somewhere in there. And that, for most, is when they begin puberty. Some a little bit later, some a little bit earlier, okay? What is the average age of first reproduction in small-town America? It's the same as average age of first reproduction in third world countries.
$15.
16, very close. So female reproductive fecundity goes up like that. Okay? But then it peaks and comes down. Until menopause, and then it goes to 0. That's why I like to talk about reproductive value. It's at the age of 16 that females have peak reproductive value. What do I mean by reproductive value? I mean, that's when you have the greatest value in terms of future reproduction. It's what you're capable of doing now, plus what you're capable of doing in the future. At the age of 37, you can still reproduce, but your future reproduction is much less, so you have less reproductive value. If you were buying livestock, you wouldn't buy some old cow or some old horse. You would want some horse that was close to this. Okay? All right. So reproductive, 16. What is generation time? How long is a generation?
1 year?
No. 16 years. A generation is defined as the mean age of first reproduction. Every 16 years is a different generation. So you're thinking to yourself, well, you know, yeah, okay, well, where I come from, not a whole lot of 16-year-old mothers. If you're in small town Missouri, if you're in small town Alabama, Arkansas, wherever, right, average age in those small towns is 16 years. That means that there are 14-year-olds out there, and 13-year-olds, and 12-year-olds that are giving birth. Okay? Probably in the high school you went to, you probably noticed, hey, whatever happened to Mary Lou? Okay? All right, so let's look at that curve. So the area underneath this curve is basically the potential reproductive output for a female. So if we want to reduce the total fecundity of a female, we need to cut the area, reduce the area underneath that curve. So how can we do that? How can we reduce the area underneath that curve? We refer to this curve as mx. That's the fecundity curve. So fecundity is a function of age. Age is x, so this is fecundity at age x. How can we reduce that curve? All right. How many kids do you have?
None.
How many kids?
None.
How many kids?
None.
What's wrong with you women? What is wrong with you?
No good men.
Don't you, go forth and multiply. It says right there in the Bible, man, be fruitful and multiply. And being fruitful does not mean being gay, okay? It means go out there, bear fruit, okay? Make some babies. It says that right in the Bible. So you guys are not Christians, obviously. There it is. Well, you're all going to hell, I can tell. Why don't you have a baby? In all honesty, why don't you have a baby?
I'm still in school, so wouldn't work out.
Because you have a different priority, right? Because you're thinking to yourself, yeah, sure, at some point maybe I might think about it, but right now I want to be this in my life. I want to have this kind of a job. This is how I want to spend my career. Okay? And in order to do that, you recognize that you need a college degree. You need an education. So what you're doing is you're delaying the onset of reproduction. Because you want a better life for yourself than all those people that are asking, you want to supersize that? You like fries with that? Okay. That's not how you want to spend your life. So, good for you. Ruth Bader Ginsburg, the Supreme Court Justice, right, that just passed away, she was the person responsible, essentially, for your rights to do that. Because she started her career, she could not get a job, okay, as a lawyer. She was first in her class at Harvard. She was married, and she had a child, and her husband got a job, and she wanted to do distance learning like other men were able to do at Harvard, and they wouldn't let her because she was a woman. And they told her, you belong, you don't even belong here in law school. Law school is for men. And so she transferred, and she went to Columbia, and she graduated first in her class at Columbia. First in her class at Harvard, first in her class at Columbia, and she couldn't get a goddamn job because she was a woman. The first case she argued, right, was about sex discrimination, but not against women, against a man. And she won. But she argued that case not as a lawyer. she became a professor of law, okay? And then she argued that case as an aid to her husband, who was a lawyer. And from that point on, her whole career was devoted towards gender discrimination, ultimately against women. And that's why you guys have the rights that you do. Because when I was growing up, you were supposed to be barefoot and pregnant and in the damn kitchen. All right. So, what you're doing is this. Actually, it's probably more like you're cutting off that part of the curve. You got plenty of, you want kids? You're fine. You're fine. You're fine. Okay? Plenty of room. But you're cutting off that first part of it. Why does that first part of it matter so much? I mean, we could cut off that. Hey, old women, women in their 30s, the hell with that. They're worn out, they're tired. You don't want your mom to be when you go to school, you don't want your mom to be old enough to be some other teacher's parent or something. I mean, we could cut off that part of the population. We could. But that wouldn't have nearly as much effect. Why?
Reproductive success is less.
Because reproductive value is less. These women aren't going to contribute much anyway. And notice what happens to the generation time. That's the key. What we're trying to do is convert the generation time from being 16 to being 18 or 20 or 21 or 22. Taking that off increases generation time. Taking that off does not. So we want to increase the generation time. That's the solution. And one way to do that is to cut off this first part of that curve. We're going to remove that. We're going to remove that fecundity. We're going to remove those potential babies from the system. That increases the generation time, and simply by increasing the generation time, the growth rate of the population is going to decrease. That's all we have to do. So how do we do that? Well, you're the answer.
Provide resources.
Well, we need to convince women to delay the onset of reproduction and get a career started. You guys are here because you're smart. What do you do for the women that aren't smart? And most of them, as most people, I'm not singling out women, most men are not smart. Most women are not. Of all the people that go to high school, what percentage of the of the U.S. population graduates high school?
60?
No, it's probably somewhere around 75%. We could look it up. When I was in high school, it was about 75%, and I'm assuming it's the same today. Of that group, what percent will finish a 4-year college program?
5.
Well, when I was in school, it was about 25%. Of that group, what percent went on to get a master's degree? About 5%. Of that group, what percent went on to get a PhD? About another 5%. So 25% times 0.75, right? That tells you what a small portion of the population actually has a college degree. And now you understand why we're in the political mess that we are. Okay? And some people are clever enough to see that and exploit it. But that's where we are. So what you need to do is you need to figure out some way to get those women, a lot of them simply do not have the intellectual capacity to be in college. How are you going to treat those women? Number one, you don't have to get all of them. You just need enough of them to bring that growth rate down. How can we get more than just the women that go to college? In terms of your lifelong earnings, if all you have is a high school diploma, what jobs are available to you? Factory work. Well, that went away, been replaced by a robot. The service industry, fast food restaurants, that's going away because of what? You go into a McDonald's, there's a little kiosk. Punch in your order, pay. Suddenly you have half the number of servers at the counter. The fries, the food preparation is being taken over by robots. Automobile production, it's all robots. That's why your cars are as good as they are. It's all robots. Manufacturing jobs are going away. Clothing, shoes, Ivanka's shoes, made in China, because it's cheaper. All that shit is no longer available. We used to have in Cape the Brown Shoe Company, that factory where the casino now is. Went away a long time ago, right? So what's available to you if you don't even have a high school diploma? What can you do? Not much. So if you're lucky and you have a high school diploma, you might end up making $25,000 a year. That's poverty, okay? If you have a college degree, how much can you expect to make?
Around 60,000.
Yeah, after a while, probably start off, depending on what the major is. If you're in engineering, you probably double or triple that, okay? If you have a master's degree, you're probably going to make around 75. If you have a PhD, you're going to make around 100. That's just per year. If you look on your lifetime earnings, the amount of money you make with each additional degree is enormous. Millions more if you have the college degree over your lifetime. And that's important. Maybe not now. All you want is enough money to buy a six-pack, you know. All right. So how do we get those women? How do we get these women that just went to high school or didn't finish high school? What do we do with those people? Because they are the biggest part of the population. What do we do with them? What do other countries do with them? Well, third world countries, tough shit, you're on your own.
Make them nuts.
No, I'm joking. What do we do with them?
The only thing I can think of is to like show them how much of a better life you'll have if you do go on to like continue something.
Some of these, they don't have the intellectual or the emotional or whatever capacity to do it. If you grow up in a household where nobody is educated, it's unlikely that you're going to, regardless of what your genetics are, it's unlikely that you're going to make it. In Germany, in Denmark, in Holland, in France, right, in Switzerland, in all those European countries, they have apprenticeship programs. So you don't go to school as long. I mean, if you go to college, you do, but if you're just going through the Hochschule, right, if you're just doing that, you're going to end up in an apprenticeship program. You can apprentice to be a bank teller, you can apprentice to be a bookseller, you can apprentice to be a nurse, you can apprentice to do all, to be a machinist, to be a welder, all these different possible, to be an accountant. All those things are not university educated, they are educated through the apprenticeship program. So when you finish your basic schooling, you become an apprentice. So for 3 or 4 years, you are an apprentice for this company. And when you finish your apprenticeship, they hire you. And you now have a good paying job. So what you do, instead of going to college, you end up in an apprenticeship program. And if you're in that apprenticeship program, you have a career in front of you. And you know that when you're finished, you're going to have a reasonable paying job. You may not be rich, but you will have enough money so that you can get a nice apartment, have a nice car, have a nice TV, have plenty of food on the table, have a comfortable life. Okay? That's what we need, I think. If you can't get people into college, you need to somehow get them into some sort of vocational training so that they have other options. We have some place like that right here in Cape. It's the Career and Technology Center, right next to the high school. You can do vocational training. The problem is we don't push it. We don't encourage people to take advantage of that. They leave high school or they, whatever, and they're so done with this, they want to get out. They're gone. And that's, I think, what we need to do. We need to shave off that part of the population. There is another thing that we can do. What else could we do? Let's continue to look at this curve. Get rid of that stuff. What else can we do here? We want to decrease the area underneath that curve. What else can we do? What I'd like to be able to do is take this curve and turn it into something more like that. In other words, I'd like to shave off the top. And the question is, how can we shave off the top of that curve? All right, how many people in here have siblings, brothers and sisters? How far apart are you?
3 years and 10 months. 3 years for my older sister and then 10 months for my younger sister.
Okay.
My mom just had a baby, so I'm 20.
So 20 years between.
21 years older than her.
Yeah.
But there's 6 siblings in total. We're all about like 3 or 4 years apart.
3 or 4. Okay.
3 years.
3. Anybody shorter than 3? 10 months, right? 2 years?
18 months.
18 months. Okay. What you can do is you can put more time between the babies. So instead of having a baby every other year, right, or every year, have the baby every 3rd or every 4th or every 5th year. Okay? Why is that putting more time between babies? Why is that a good thing? Why is it good for the mother?
Let your body recover.
Give your body a chance to recover, restore all those calcium loads and whatnot. Okay, so that's one. What else? What's it like caring for a baby?
Tiring.
Tiring. You don't get a lot of sleep. You're worn out. You're frustrated. You're trapped. Can't go anywhere. Your whole life is consumed by diapers, right? And screaming babies and feeding, all that kind of stuff. It's work. So if you can spread them out, right, it's better for the baby because the baby gets more attention. If you have a sibling that's only 10 months younger than you, somebody was getting shortchanged on attention. Okay? If you're the only baby in the house, you're getting all the love. If there are 2 of you, you're only getting half of it. Okay? So this gives you ammunition to complain to your parents
Yeah, I
about.
was gonna say story of my life. Honestly.
Okay? So if you can reduce, right, or you rather increase the time between babies, you'll take off the top of that curve, and that too reduces the total fecundity of the population. So you have 2 options. Put more time between babies, or number 2, delay the onset of reproduction. And both of those are relatively easy to do without offending anybody's religion or anybody's morals or anybody's whatever, okay? How do we delay the onset of reproduction? Get more women onto career paths. Give them more opportunities. Let them become welders. Let them become, apprentice bakers or apprentice accountants or apprentice nurses or something like that. Anything, right? They can do body work, right? I mean, if you go, they can become computer programmers, coders, whatever. All those sorts of things are available through that Career Technology Center. And other cities with bigger systems have even more offerings. So that's what. The other way is to convince people that you're better off, happier, healthier, your kids will be better if you put more time between your babies. How can you achieve that?
Like the 5-year bars and stuff in your arms.
Yeah, I mean, we can't even convince people to take vaccines. That we can't even convince people to get vaccinated. I know it's stupid, okay, but there it is. Yeah, if they give me a vaccine, I'll be autistic. Mm-hmm. Well, public education system, somehow public service announcements, changes to the tax code. You get huge tax benefits where you don't pay taxes for every year that you have between babies, right? Up to 5 years or something like that. Something, right? You don't have to have every woman do it. You just need more women to do it. Okay. Good. Let's look at the other part of this curve. How much time do I have? I have a few minutes. Let's look at the other part of this curve. And that is survivorship. So we've talked about fecundity, mx. Now I'm going to talk about what's called LX, the survivorship function. So this is age. So births and deaths. Now let's talk about the death part of it. So for humans, for white, first world country humans, it looks like this. So given that you're born, the probability that you'll see your next birthday is almost 1. Given that you're 1, the probability that you'll see your second birthday is almost 1. And so on. Up until you reach a certain age, and then things start to go south. That's probably around 50 or something like that. Things start going downhill, okay? This is where you're on the downhill slide. There you are, about 80, and things are looking pretty grim. I have the guy that lives behind me. Two 80-year-old guys live behind me. One guy is totally with it. He's upright and ambulatory, good shape. He's out there doing all kinds of shit, man. He's excellent physical. First time I saw him, I figured he was 60. He's 80. He looks awesome. The guy that lives right next door to him is also 80. He can barely stand up. He's standing there with a cane. He's doing all that. He looks like death warmed over. Sweet old guy, but goddamn, don't cough on him because you'll knock him right over, man. He's that frail. On the downhill slide. The probability that he sees his next birthday, probably around 10% or something like that. Okay. What does the curve look like for women? If that's the curve for men, what does it look like for women?
It's even longer.
It's actually a little bit better. Why? Why do women have higher survivorship than men? Even though physiologically women do so much more than men. Childbirth is risky stuff, and yet they have better survivorship than men. Why do males have lower survivorship than females?
Risky behavior.
Risky behavior. Insurance companies know that. How much do you pay for your car insurance compared to any woman in this class? Probably about double. Why? How far, if you look at the odometers on women's cars and then look at the odometers on men's cars, men drive enormously more than women. When I was in high school, Friday night, I'd fill the tank on my car 2 or 3 times. Man, we'd go down cruising LA, the Sunset Strip, Wilshire Boulevard, checking out the babes, all that good shit. A lot of miles on that car, okay? This is what guys do. They're scouting for female. What do male deer do? They're all over the damn place, scouting for all the females. That's what guys do. Drive fast, men drive fast. Women drive sanely, okay? Men take risks. Women take fewer risks, okay? So it's that risky behavior, maybe it's risk aversion in the females, but that risky behavior reduces the survivorship curve for white males. What does the survivorship curve for African Americans look like? What does the survivorship curve for Native Americans look like? Why?
Poverty.
Pardon?
Poverty.
Poverty. Okay. Not knowing where the next meal comes from, not having running water, living in dangerous places, all that kind of stuff. Okay? So that drops the survivorship curve dramatically. So actually what we want then to control population growth is move everybody into poverty. Sure, that would be good. That would work. Anybody here ever been on an Indian reservation out west? You should. Just drive through. Don't stop. Just drive through. Okay? And get a sense for how a huge portion of the American population lives. Okay? I mean, talk about extreme. I mean, these people, they don't have water, no running water, no indoor plumbing, anything of that sort. Right? Their roofs on their houses are going to be, you know, just corrugated tin or something. Their houses, most of them live in adobe houses, so made with mud and straw. Okay? A lot of them don't have windows. Okay? And they're managing it. They're doing. But you get a sense for how privileged you are, right, compared to them. And keep in mind that they were here first, right? That we basically stole their property. I know, we won, they lost. Okay, so now we have these two things, right? We have our survivorship curve. Everything that we do in modern medicine is designed to get the survivorship curve more like that. At some age you're supposed to die, I suppose. But that's what we're trying to do. That's what modern medicine is all about. Trying to improve that survivorship function. Let's put it all together now into one simple equation. Okay? Let's talk about how we can write a better equation for population growth. That equation looks like this. What we're going to do is talk about births to females at time t. So we're defining a function called births to females at time t. Okay? Plus, that's going to be equal to g at t. And for right now, we're going to ignore that. Ignore it. come back and talk about that briefly. What it is, GT, that's just what's referred to as the initial cohort, or the founding population. And after we're into this system for a couple of generations, it doesn't make any difference anymore. It disappears. Plus the sum of births to females from T minus X time units ago. So we're going to look at females that were born X years ago. So births to females X years ago times LX times MX. So all we're doing is this. For each age class of females, for 1-year-old females, so we're going to count up how many 1-year-olds there are, times the probability that they survive to the age of 1, times the probability that they give birth at age 1, plus the number of females that were born 2 years ago, times the probability that they survive to the age of 2, times the probability that they give birth at age 2, plus the number of females that were born 3 years ago, times the probability that they survive to the age of 3, times the probability that they give birth at age 2. That's all 0. Plus 0 up until about 12. The number of females born 12 years ago times their probability of surviving to the age of 12 times the probability that they give birth at age 12. Suddenly we have a positive number. Now we're going to do that all the way up to the age of 100. Well, by the time you get to the age of 100, it's all 0 again. So basically, the only non-zero part is going to be those years when the females are giving birth. So we're adding up the babies. This is a special kind of equation called a renewal equation. That is the renewal equation. So the renewal equation, all we're doing is adding up how many babies of a certain age there are, how many babies were born so many years ago, times the probability that they survive till now, times the probability that they give birth now. We're adding that all up for babies that were born 0 years ago to babies that were born 100 years ago, or 110, whatever you want. We just add up all those births, and those become the next generation, the next year's babies. And we do that for every year. And when we do that, we can model population growth. And what do we come up with? Exactly the same sort of population growth that we see with the exponential curve, with the difference. Now we can study what affects changes in survivorship and what effects changes in fecundity will have. One of the assignments that we will do, another opportunity for you to get 3 points, is this. I will put that equation in an Excel file. We will use data that you will get off the internet. You will choose a country. This is not due this week, not even due next week. But in the near future, you're going to get data from another country, either first world, second world, third world, I don't care. You're going to find out what the age-specific fecundity is and the age-specific survivorship. You're going to plug your numbers into the Excel spreadsheet and predict over the next 100 years what's going to happen to that population. Okay? So we're going to use this model to predict population growth in a different country. All right. That's all she wrote, kids. Are you guys the Friday lab or the Wednesday? I will see you guys on Wednesday then.
Did we need to actually turn in the prairie dog and marmot?
Yeah, your ethograms, your sequential behavior stuff.
Yeah.
Yes. Those are all points. So if you don't have it, get it to me by Wednesday, okay?
So you wanted us to do the marmots? I thought you just wanted to watch the video on.
No, you need to do the marmots.
Okay.
Yep, very good.